Welcome to Agron Infotech. In this tutorial you will learn how to plot a bar graph for main and interaction effects. The video tutorial will comprise of following topics: importing data and formatting variables, analysis of variance model, LSD mean comparison test, arranging treatment groups from LSD test, computing mean and standard error, visualizing bar plots. Before importing the data set, I often recommend to first clear all the objects or values in global environment using remove function. Graphics off function will shut down all the open graphics devices. Clear everything in console using shell function. The example used in this tutorial shows the MPI activity of enzyme in 3 different genotypes. The genotypes of amphipods were separated by gender to know the effect of gender on the enzyme activity. Now let's import the data set using read CSV function. I have already saved this data file in CSV format within the working directory. The file arguments specify the file name with extension CSV. In header argument you can set a logical value that will indicate whether the data file contains variable names in the first row. In my case the data file contains variable names in the first row, so I shall use true for this argument. The head function will print the first 6 rows of the data set. You can attach database to the R-search path using attach function. This means that the database is searched by R when evaluating a variable, so objects in the database can be accessed by simply giving their names. I shall use two-way analysis of variance model for this data set. To apply the analysis of variance model, load the stats package using library function. Fit the analysis of variance model using AOV function. Within parenthesis write the formula specifying the model. Here this formula represents the response variable, which is separated by genotype plus gender plus the interaction term for both factors. In other way, you can reduce the formula by just using the interaction term by putting multiplication symbol between the two factors. Both commands will provide the same information. Use ANOVA function for the above model object to print the results. Now let's compute multiple comparison of treatments by using least significant difference test and a grouping of treatments. To apply this test, load agrically package using library function. LSD test function is used for multiple comparisons of treatments. This function requires some arguments. In Y argument you can specify model or use response variable name. In treatment argument specify the first factor variable. To set the value for error degree of freedom, write df residual with model object after $sign. To set the value of error mean square, divide deviance of model object with residual degree of freedom. I shall use the default value for alpha argument that represents the 5% level of significance. In method argument for adjusting probability value, I shall use Bonferroni, which is most commonly used method. Set a logical value for group argument to specify grouping of treatment means. Set a logical value for console argument to print the outputs. To compute multiple comparisons of treatments for the second variable factor, you will need to just specify the treatment argument. Type the second variable factor name instead of first variable factor as used in previous command. Rest of all arguments will remain the same. This will print the outputs for the second variable factor, that is gender. To compute multiple comparison of treatments for interaction term, again use the same arguments as used in previous command except the treatment argument. In treatment argument specify the interaction term as used in model object for analysis of variance. This will print the outputs for the interaction effect. Next step is to arrange the treatment groups in the original order of treatments rather than ranked order of LSD test result. This will help while adding alphabets from treatment group in the same order as the order of treatments in the plot. Connect the group component from LSD object with group by and arrange commands for the same component using the given pipe operator. Print function for this object will show the original order of treatments. Use the same commands to arrange treatment groups in original order for the second factor variable. For this use treatment group component of LSDB object. Print function for this object will show the original order of treatments. Use the same commands again to arrange treatment groups in original order for the interaction term. Use LSD group component for interaction term. Print function for this object will show the original order of treatments. Before visualizing main and interaction effects, first compute mean values and standard error. For this, load the library dplyr that states the grammar of data manipulation. Connect dataset to a command that will group it by genotypes and then connect with summarize function. For connection we shall use this pipe operator. In summarize function the objects for mean and standard error will be created. Print function will display the results for this object. Similarly, get mean values and standard error for second variable factor using the same command except connecting the data set to group it by gender using pipe operator. Print function for this object will display the results. Again use the same command for interaction term. Here you will connect the data set to group it by genotype and gender using the pipe operator. Print function for this object will display the results. Let's start to display the main and interaction effects using grammar of graphics function. This will require to load the package ggplot2. Create an object using the grammar of graphics function. This function requires dataset and some aesthetic mappings to use for the plot. In aesthetic mappings function the argument x specify the variable labels and argument y specify the variable mean values. Print function will print a blank plot showing x and y axis labels. Now let's add layers to this plot object. For plotting bars use geometry bar function. In stat argument set the value as identity to leave the data as is. In color argument specify the color for borders of the bars. The position argument specify the position adjustment, either as a string, or the result of a call to a position adjustment function. The argument width specify the width of the bars. Printing this layer with plot object will display bars on the plot. Let's add the second layer to show error bars on the bars of the plot. For this use geometry error bar function. In aesthetic mappings you can specify the maximum and minimum values to show the heights of the error bars. Use the same position argument as used in previous commands so that the error bars could place in the center of the bars. You can adjust width of the error bars by setting the value for width argument. Printing this layer will add error bars. Let's change the main title, x, and y axis labels of the plot. For this use labs function. In title you can specify the main title of the plot. For x and y argument specify the labels to be used for x and y axis. Now let's add alphabets from mean comparison test on top of bars. For this use geometry text function. In aesthetic mappings you can specify x, y, and label arguments. The x argument specify the levels of the variable factor. In y argument specify the y-axis position of the alphabets. I am using mean values plus standard error for this argument. This will place the alphabets on the top of error bars but not above of it. To place the alphabet slightly above the error bars using vertical adjustment argument. Set the value 0.5 with minus sign for this argument. In label argument use the matrix of LSD group alphabets as arranged in original order of the means. Use the same position argument as used in previous command for plotting bars. Print this layer will show the alphabets on top of the error bars. The same functions will be used to plot bar graph for second factor. For second factor first create an object using grammar of graphics function. Use same arguments in this object changing the values to represent the second factor data set. Print function will display the empty plot for this object just showing the x and y axis labels. For adding layers to this plot object use the same functions as used in adding layers for first variable factor. Just change the arguments representing the values of factor b instead of factor a. This will result in printing bars where height of the bar represent the mean values for gender. Similarly set the values of the same geometry error bar arguments to print error bars on the plot. Here you will set the values for these arguments according to the second factor. Use the same labels arguments and set the values according to the second factor to print main title, X, and Y labels. To display lettering or alphabets from LSD test, again use same arguments except the setting the values for factor B. Printing this layer will result in placing alphabets on top of the error bars. To plot bar graph for interaction term, again create an object using the ggplot function. However, you will change the arguments to represent the interaction data set. In aesthetic mappings, define X, Y, and fill arguments. The argument X specify gender or the variable name that you want to place on X-axis. In Y argument, set the mean values for interaction term. Fill argument specify the factor used to change the set the color and fill of geometry elements on a plot. I shall set the second variable factor for this argument. Print function will display the empty plot for this object, just showing the X and Y axis labels. Now add the layers to this plot object. Use same arguments for geometry bar as used in previous command to plot bars. Now I shall a different layer for adding color for fill and changing legend text. For this use scale fill manual function. In values argument, set the fill color for the bars. In labels you can specify labels for the legend text. Print function for this layer will add fill color and labels for legend text. To add error bars on top of the plot bars, use geometry error bar function. You can specify settings for aesthetic mappings, position, and width of the error bars. In aesthetic mapping, set the maximum and minimum values for error bars on Y-axis. I shall set these values by adding and subtracting standard error from height of the bars. Specify position argument same as the value used in previous command for plotting bars. This will result placing the error bars exactly on the same position as the bars were plotted. You can change the width of the error bars by setting the value for width argument. Printing this layer will add error bars. To add main title, X, and Y labels, use the same arguments as used in previous commands while plotting main effects. An additional fill argument can be specified for legend title. Printing this layer will add main title, X, and Y labels and legend title to the plot. To add alphabets taken from group component of interaction LSD result, use geometry text function. Use the same arguments which were specified while adding this layer in plotting main effects, except specifying the interaction component instead of main effects. Printing this layer will display the alphabets on the top of error bars. I hope you would have learned how to plot main and interaction bar graphs, adding error bars and placing mean comparison alphabets. If you have any question, feel free to ask in the comment box.